discuss about a simple problem. A roller of weight 10 kilonewton rests on a smooth horizontal floor and is connected to the floor by the bar AC as shown in the figure. Determine the force in the bar AC and the reaction from floor. If the roller is subjected to a horizontal force of 5 kilonewton and an inclined force of 7 kilonewton as shown in the figure. So, in that figure they given 7 kilonewton and 5 kilonewton. 5 is acting in the horizontal and 7 kilonewton is acting 45 degree from horizontal, and this is the picture, and the force AC is acting 30 degree from horizontal. We have to find this AC, right, FAC, this we have to find. Clear? So, first we have to draw the free body diagram. Already in our previous video, as I said, wherever the supports are there, we have to consider the reaction force. Clear? So, first we have to draw the free body diagram, right. So, this is center point and 7 kilonewton is acting, 7 kilonewton is acting with 45 degree inclination, and this is 5 kilonewton, and the weight of the ball is acting downward, right. So, this is W acting downward, and the reaction forces, I mean supports are there, right, at point C. So, from C or C, this is called the reaction force from point C, and one more force FAC is acting towards the ball, and this is FAC, and the inclination which is equal to with respect to 30 degree with respect to horizontal, right. So, this is the free body diagram. So, here two forces acting inclined, 7 kilonewton is acting inclined 45 degree with respect to horizontal and 30 degree, I mean FAC is acting 30 degree inclination with respect to horizontal. So, as we know that the force if the force is inclined, then we have to resolve that force into two components, one is horizontal component, another one is vertical component, right. So, this 7 kilonewton is divided into horizontal component and vertical component, right. So, this is 45. So, draw a line, this is called as a vertical line. So, opposite side which is sin 45, I mean 7 sin 45 degree and 7 cos 45 degree, right. So, this 7 kilonewton is resolved into two components. Similarly, FAC is resolved into two components, one is horizontal, another one is vertical. So, this is horizontal and this is vertical, right. So, opposite side this is FAC sin 30 degree and this is FAC cos 30 degree, right. So, W is acting vertically and RAC is acting vertically, but in the opposite direction of W, and FAC sin 30 which is acting upward, and 7 sin 45 is acting downward, right. So, these are the vertical forces. And what about horizontal forces? Horizontal forces 5 kilonewton is acting horizontally and FAC cos 30 which is acting horizontally, right. And one more 7 cos 45 which is acting horizontally. 5 kilonewton and 7 cos 45 which is in the opposite direction. So, now, so this is the free body diagram. Let us check. So, 10 kilonewton is acting downward which is called as a weight of the body, right. So, this is weight of the body, and 7 kilonewton, 5 kilonewton, and this is AC, right, and this is reaction force we discussed, right. So, now we are going to solve this, right. Clear? So, first let us take summation of horizontal forces equal to 0. So, consider only horizontal forces 5 kilonewton. See, for example, take the direction which is towards right side, then we will take positive, right. Suppose the direction which is in the left side, then we will take negative. Clear? So, now 5 kilonewton is positive because acting right side. So, 5 kilonewton, right, and FAC cos 30 is also acting towards right side. So, plus FAC cos 30 degree, right, and see here 7 cos 45 is acting left side. So, minus 7 cos 45 degree, which is equal to 0, right. So, now we want to calculate FAC, right. So, FAC which is equal to 7 cos 45 minus 5 divided by cos 30 degree, right. So, 7 cos 45, what is the value? Cos 45 into 7. So, 4.949 minus 5 divided by cos 30 degree. So, what is the value? Minus 5. So, this is divided by cos 30. What is the value? So, minus of 0.058. So, everything is in terms of kilonewton. So, kilonewton, right. So, what is the value? FAC which is equal to minus of 0.058 kilonewton. So, this is the value, right. How the magnitude comes in the negative value. So, which means, so negative sign which indicates this FAC is not towards ball, which is towards the opposite direction, right. So, FAC which is not towards the ball direction, which is in the opposite direction. This is not correct. So, this is correct, right. So, if we want to calculate the reaction force, then we have to calculate sum of vertical forces which is equal to 0, right. So, sum of vertical forces, which means RC, right, minus W, because upward force we will take upward force which is positive and downward side which is negative. So, RC is acting upward, that is why I am taking positive, and W is acting downward. So, that is why I am taking negative. So, what are the values acting downward? This 7 sin 45 is also acting downward. So, that is why 7 sin 45 degree, and this FAC sin 30 which is acting upward. So, that is why take positive, right. FAC sin 30 degree which is equal to 0. Now, we know that the value of FAC, right. Substitute this value, and W we know that everything is known value except this R value, RC value, then RC which is equal to we can find, right. See, FAC value which comes in the negative value, then since the value of S is negative, the force exerted by the ball is not push value, right, which is not towards the ball, which is towards downward, right, and the vertical forces which is equal to 14.979 kilonewton, right. So, next problem, a 400 Newton sphere is resting in a trough as shown in the figure. Determine the reactions developed at contact surface. Assume all the contact surfaces are smooth. Here two contact surfaces are there, right. So, as we discussed already, wherever the supports are there, we have to take the reaction forces, right. So, W is acting downward, right. So, the ball is having some weight. So, W is acting downward, and we have two reaction points, one is at point 1 and another one is point 2, right. So, W is acting downward, right, W, and the reaction force which is perpendicular to the surface, right, and another force which is perpendicular to the surface. This is R1 and this is R2, right. So, R1 is acting 60 degree, right. So, here 60 degree incline and here 45 degree incline, right. So, two forces are acting. So, draw a vertical line, then this is which is equal to 45 degree, right, clear, and here this is perpendicular, and moreover the plane is inclined at 60 degree, right. So, draw a vertical line, then this is inclined at 60 degree, right. So, here one more this is 60 degree, right. So, this is W and this is R1 and this is R2, clear. Now, draw a vertical line, right. So, what is the value of this? This is equal to 40 45 degree, right. And what is the value? This is equal to 60 degree, right. Now draw a horizontal line. We know that the included angle between the bottom, which is equal to 180 degree. So we have to find this, right, because we know that this is 90 degree and this side 90 degree, right. So we have to find out this and this, then only we can calculate the included angle between W and R2, W and 60 degree, right. So 90 minus 60, 30. So this side 30 degree and this side 45 degree, 90 minus 45, 45, right. So now three forces are acting in the system, so we can apply the Lami's theorem, right. So Lami's theorem, we know that W divided by sine opposite side, I mean the included angle between R1 and R2, if we want to take W. So included angle, what is that? 60 plus 45, right. So 60 plus 45, 105 degree, which is equal to, now I want to take R1. So R1 divided by opposite, I mean include angle between W and R2. What is the value? Sine of, this is 90 plus 45, right. So 90 plus 45, 135. Now I want to take R2. R2 divided by the included angle between W and R1. What is the value? 90 plus 30, which is equal to 120. So 120 degree, right. Now W, we know that 400 Newton. So 400 divided by sine 105. Sine 105, we know the value, sine 105, which is equal to 0.965. So 0.9659, which is equal to, now I want to equate this two, then we can calculate R1. Then I want to equate these two, then I will calculate this R2, right. So R1 divided by sine 135, right. So sine of 135, which is equal to 0.707. Now R1, which is equal to, what is the value? 400 into 0.07707 divided by 0.9659. So 292.7, right, 292.7 reaction force Newton, because W given in Newton, right. So this is Newton. Now I want to equate this one and R2, right. So same value, 400 divided by 0.9659, which is equal to R2 divided by sine 120. What is the value of sine 120? Sine 120, which is equal to 0.8660, right. Now R2, which is equal to 400 into 0.8660 divided by 0.9659, R2, which is equal to 358.62 Newton, right. So R1, which is equal to 292, R2, which is equal to 358, right. So let us check the answer. R1, which is equal to 292 and R2, which is equal to 358, right. So now we are going to draw a free body diagram for this case. This is a special case. Two rollers are there, two identical rollers P and Q, each of weight W, identical rollers, which means the weight which is equal to W, right, and are supported by an inclined plane and a vertical wall as shown in the figure. Assume all the surfaces to be smooth. Draw the free body diagram of roller Q, roller P, and the roller P and Q are taken together, right. So this is roller Q and this is roller P. Two rollers are there, then inclination of the plane which is equal to 30 degree, right. So as we already discussed, wherever the supports are there, we have to take reaction forces, that reaction force which is perpendicular to the plane, right. So we have to consider this reaction force at point C, this is called as RC, right, and we have to consider this point B, we have to consider RB, right. So one more support is called, one more support at A, so reaction force RA acting at point A, right. So RA, RB, RC, and one more supports, that is called as point D, right. So when we are considering the roller Q, then the reaction force RD is acting towards the ball Q, and if suppose we are considering ball P, then the reaction force at point D is acting towards the ball Q, right. Okay. Then now we have to draw the free body diagram for the individual rollers Q and P, right. Now free body diagram of the roller already we discussed. So the RD, it is a support. So when we are considering the roller Q, then the RD is towards Q. When we are considering the roller P, then the RD is towards the roller P, right. So W is acting downward and we are considering the reaction force at C, B, right, and D, right. And the free body diagram of the roller Q. So as I said, RD is acting towards the ball, right, and W is acting, and the reaction force at A is towards the ball. Wherever the supports are there, reaction force is acting towards the ball, right. So here the inclination which is equal to 30 degree, right. So we are considering both of these two, right. Then this is the free body diagram combined of these two, and see, join this E and F which is parallel to the plane. So the inclination which is equal to, draw a horizontal line. So this is 30 degree because RD is parallel to this plane, right. So now here you have to draw a vertical line and see the reaction for the reaction force RB which is perpendicular to this plane, but the plane is inclined at 30 degree. Then draw a vertical line and this inclination which is equal to 30 degree, right. See, for example, join this line, right. So this is 90 degree, right, clear, and this is 30 degree, right. And what is this angle with respect to horizontal, which is equal to 60 degree, because 90 plus 30 120, 120 plus 60 180 degree, right, clear. And what about this? Draw a vertical line and this is which is equal to 30 degree, right, clear. And draw a horizontal line here and here, and this is we know the 30 degree and which is equal to 30 degree this side, right. So this is how we are going to draw a free body diagram, right. This is the problem which is related to the previous discussion. The two identical rollers P and Q, identical, which means W which is equal to 1000 Newton for roller Q and roller P, right. P and Q, each of weight W are supported by an inclined plane and a vertical wall as shown in the figure. Find the reactions at the points of supports A, B, C. Assume all the surfaces are to be smooth. So as we discussed earlier, we have to draw the free body diagram for roller Q and roller P, right. So this is the free body diagram. As I said, how to calculate the degrees. So this is the plane which is inclined at an angle of 30 degree, right. Then the reaction force at point B which is perpendicular to the surface, the inclination of the plane which is equal to 30 degree, then draw a vertical line, then this is similar to the 30 degree, the same angle, the inclination, then join these, this is 90 degree and 90 plus 30 which is equal to 120, then 180 minus 120 which is equal to 160, right. And draw an horizontal line. This is RC which is horizontally acting horizontally, this is 1000 Newton which is W which is acting straight, right. And this is RD, right. So RD which is, draw a horizontal line, right, and join this E and F, that is pass through the point D, right. So this line EF which is parallel to the plane AO, right. So the inclination of this plane which is equal to 30 degree. So draw a horizontal line and this inclination which is equal to 30 degree and draw the horizontal line from this side and this is equal to 30 degree, right. And what is this angle? This angle which is equal to 30 degree. So that's why they mention here 60 degree, right. Similarly, we have to draw the free body diagram of roller P, right, similar to this. Now we have to calculate, right. So free body diagram of roller B, and now sum of horizontal forces which is equal to 0. So, how many horizontal forces are there? So, this RD is acting at inclination and RA is also acting with some inclination, right. So, we have to divide this RD into two forces, horizontal and vertical, and RA is also acting two forces, result in two component, one is horizontal, another one is vertical component, right. So, RD sin 60 acting in this direction and RA acting in this direction, right. So, that is why RD sin 60 minus RA sin 30 which is equal to 0. So, RD which is equal to RA sin 30 divided by sin 60. So, we do not know RA, then the formula, I mean the equation what we got, RD which is equal to 0.57 RA, right. Similarly, summation of vertical forces which is equal to 0. How many vertical forces are there? So, 1000 Newton is acting downward, and similarly two components are there, vertical force of RD and vertical force of RA, right. So, equate that RD both are in the same direction towards upward, that is why here plus. So, RD cos 60 degree plus RA cos 30 which is equal to downward, which is 1000, because 1000 is acting downward and remaining RD and RA which is acting upward, that is why this, right. So, now substitute RD value in terms of RA here, then you got RA value, then substitute RA value in this, you will get RD, right. So, this is the free body diagram of P and we got RA and RD. Now, take the roller Q. Similarly, we have to solve the same problem. Summation of horizontal forces equal to 0 and summation of vertical forces equal to 0. Sum of horizontal forces, this is one horizontal force and this RD is acting inclination with respect to 60 degree, then this RD is resolved into two component, one is horizontal and vertical. Similarly, RB is also acting inclined. So, that is why divide into two component, horizontal and vertical, right. So, now RD sin 60 plus RB which is equal to RC. This RD and RB both are in the same direction and RD is in the opposite direction, that is why this equation, right. So, we convert RC which is equal to 0.5 RB into plus 432, right. This is the equation. Then sum of vertical forces which is equal to 0, right. Then substitute this RD value in this, you will get RB, right. So, substitute this RB value in this equation and you will get RC, right, clear. So, this is how we have to solve the problem. Okay. Thank you.